All right, so thinking back to Gen Chem 101 again, you learned probably just briefly about isomers. So remember, isomers are things that have the same formula, but different structures. So we're going to learn a lot of different isomers here in these transition metal compounds. So isomers we have up here at top, and we can actually split this up into two different types of isomers. On the left, we'll have structural isomers. And so structural isomers will have different bonding. And then on the right side, we have stereoisomers. In stereoisomers, all the bonding is the same, but there's a different spatial arrangement. And the topic of isomers is something that you'll go over a lot more if you get to organic chemistry. It's a huge topic there. These structural isomers can then be also broken up into coordination isomers and linkage isomers, while the stereoisomers can be broken up into geometric or optical isomers. So we'll take a look at each one of these one at a time, example by example, right? So let's take a look at optical first. Optical isomers are non-superimposable mirror images. That says non-superimposable mirror images. So let's take a look at what exactly that means. This is something that you'll see in OChem quite a bit and is an important topic for OChem. So we're going to draw our two metal centers, and then in between here, we're going to have a mirror, and they're going to be mirror images of one another. So up top, we're going to just say something A is attached here, and so looks the same over here. And then we're going to say B is attached in this direction. And so if we think about the mirror image of this, B would be closer like that. And then it's going to be a tetrahedral shape. So we're going to have C pointing out of here. If you think about what the mirror image of that would look like, C would be there. And then if we had D in the back here, we could see D would be in the back here. So you can see they are mirror images of one another. Think about it. Think about your hands. Your hands are mirror images of one another. If you're looking at your hands, you'll see that they are mirror images of one another. So let's see what happens when we try to rotate this bond right here so that they're in the same kind of orientation as the other one. And let's see if this is the same molecule or not. So we're going to rotate 180 degrees. And so when we do that, we're going to put B right here, right? So we're going to rotate this guy 180 degrees. And so you can see B will end up there. So if you think about C, if you think about where C is going to end up, if you rotate it 180 degrees, if it's pointing out of the board now, it's going to point into the board after. And vice versa for D. If D is pointing into the board right now, it's going to point out of the board later on. And so what you can see about these two compounds is that they're not the same. Right, this one has C pointing out, this one has D pointing out. So the bond is all the same, but the spatial arrangement is different. And think about your hands, right? Think about your hands. One is left-handed, one is right-handed. Overall, the properties of these kinds of stereoisomers aren't too different from one another. The main thing where it shows its importance is biological applications. Biological applications really care about the stereochemistry of the molecules.